Welcome to part 14 of this Dave on Data tutorial series, a Python crash course. This video is a long one because it is a pandas tutorial. If you're not familiar with pandas, it is the library used in Python for working with entire tables of data. You can think of pandas as being the functionality that's equal to Microsoft Excel or SQL, Structured Query Language, or SQL to work with entire tables of data. So as you might imagine, skills with pandas is an absolute requirement for using Python for analytics and data science. I need to start this video with some housekeeping. First up, you need to get the files. This pandas tutorial uses data, CSV files built from Microsoft's AdventureWorks sample database. It's a relatively good example of business data in general, which is why I use it in this tutorial. If you want to get the files, and you need to get the files if you want to follow along with the code, there's a link to the GitHub in the description below the video. Pop out there, download the CSVs, and then you'll be good to go. Now next up, this video is long, more than 2.5 hours. And the reason for this is I'm trying to follow the 80-20 rule in this tutorial series. The 20% of Python that is useful 80% of the time in analytics and data science. And when it comes to pandas, that's just a lot of stuff. So rather than make this video too short or make a whole bunch of different parts, I just crammed it all together in one video at 2.5 hours. Now notice that because of this, I've done minimal editing to the video. And that's simply because 2.5 hours would just take me days upon days upon days to edit. So I've just done minimal editing. So I apologize in advance. You're going to see me make mistakes. There's going to be some pauses, that sort of thing. But hopefully you'll still get value out of the video. And lastly, and most importantly, this tutorial is designed for you to follow along. You really should type the code as I type it because you learn Python by writing Python. Next up, I want to recommend this book. If you want to learn more about pandas than what I can cover in this tutorial, and believe me, there's a lot more that you could learn, get this book, Effective Pandas by Matt Harrison. I have no financial stake in this whatsoever. I own this book. You can see it right here. I took a picture of it on my dining room table. This is a great, great book. It goes into a lot of detail around things that I just couldn't cover in the tutorial. And if you really, really want to get good at pandas, get this book. It's well worth it. I will also mention this book once again at the very end of the video. So as I mentioned in the intro, pandas is the library in Python for working with entire tables of data. And here's an example from the AdventureWorks DW database. This is a table of reseller sales. So AdventureWorks is this hypothetical company that sells bicycles and bicycle-related products, and they have resellers, bike shops, for example, retail bike shops. And this is just a data frame, a table of data that represents individual sales, individual line items in sales. And not surprisingly, just as you see with technologies like Excel or relational databases, tables of data are the fundamental building blocks of all analytics and data science. Well, I shouldn't say all, but the vast majority of real-world useful analytics and data science use entire tables of data. And in Python, pandas is the library that allows you to work with this. And in particular, there is a class called DataFrames. Panda DataFrames represent entire tables of data. So when we load this CSV data up into pandas, what we get is a pandas data frame object. And that allows us to work with entire tables. We can change the columns, we can clean the data, we can join or merge different data frames together, all kinds of cool stuff. So this is our basic object, the most base object that we use in analytics and data science with Python, and that is a pandas data frame. But that's not all. While data frames are central to what we work with in terms of analytics and data science using Python, it's not the only thing that we use. There's also a really commonly used object in pandas known as the series object. And the way to think about this is consider a table. So this is another one of the tables of data from the AdventureWorks DW database. This one is actually the resellers. So each row in this particular table represents like a bike shop that sells AdventureWorks products on their behalf. And what we can see here is that we got a table of data, and we can think of tables as being a container for columns. So you can see right here a subset of the resellers table, and I have 1, 2, 3, 4, 5, 6, 7, 8 columns. So this container, this data frame, this table is a container for individual columns. The pandas library takes a similar approach by using objects of the series class to represent entire columns. So in turn, you can think of a data frame object as being a container for series objects, or a table as a container for columns. So table, columns. The series object is awesome. The series class is awesome. It offers so many features for working with entire columns of data. For example, if you have a numeric column, you can use items around calculating the mean or the min value or the maximum value, that sort of thing. There are lots of functions and functionality for manipulating textual or string data. There's lots of functions for working with datetime data. All of that sits on the series objects because we're talking about columns. So if we think about this once again, right, this is our data frame as we saw, and then this is an individual series object. So this is a column of data called reseller key, and it would actually have a name, it has values, and this is an object contained within the data frame. This is also another series object. This one happens to be a numeric column here, and this one happens to be text or string data. So what we can do is start thinking about how we work with data frames and then the series objects within them as we work with our data, clean our data, merge our data, all the sort of things that we need to do as a precursor for our analytics and data science. The last thing to know conceptually about data frames and series objects is that rows are also series objects. And once again, we can think about this logically, conceptually. A table of data is really a collection of rows and columns. And if a series object makes natural sense to represent a column, it also makes natural sense to represent an entire row as a pandas series object. So we can think of this as being a data frame as being a two-dimensional object. We have a bunch of series objects, each one representing the columns, and then we have a bunch of series objects representing the individual rows. Now, generally speaking, we tend not to work too much with pandas series objects in the context of rows. The vast majority of what we're doing is working with entire data frames or columns within data frames. But I cover this just to be complete. Also know that you can also think of a pandas data frame as a collection of series objects representing the rows of data. Okay, now with that conceptual framework, let's just jump right into the code. Okay, so you can see here I've started a brand new Jupyter notebook for this particular tutorial video, and I'm going to be using the same notebook throughout this long tutorial. So first up, we're going to go ahead and set up a section here using some Markdown, and we're going to call this Fundamental Pandas. All right, and here's the thing. We need to make sure, if you're following along to do this, you need to download the CSVs, and those are located in the description below the video where you can get these. And you need to put them in the same folder as your notebook. Exclamation point for emphasis, okay? I'm not going to be fiddling with file paths or anything like that. So first thing that we need to do is we need to tell Python that we want to load the pandas library. So we say, hey, import pandas as PD. You don't have to call pandas PD. You don't have to use this alias. However, it is pretty much standard practice. It's the de facto standard in Python coding. So what we're going to do is load the reseller sales data. Okay, and I'm just going to create a data frame object, which I'm going to call reseller sales. And what I do is I access the pandas read CSV function. And that, not surprisingly, reads into CSV. And this function has a ton of functionality. In this video, I'm only going to scratch the surface of what's going on. You can also ask ChatGPT for more information about it, or you can go old school and just Google it. In a future video, I'm going to demonstrate how to source data into pandas data frames from a SQL Server database. But for right now, to keep this video simple and accessible to a broad audience, I'm just going to use the CSV files that you can download from the link in the description below the video. And it is called reseller sales because this file right here is co-located in the same folder on my laptop as the notebook. It's going to work just fine. So I can go ahead and I can run this code, and it'll take a second. And I've loaded up a data frame called reseller_sales with data from this CSV. Now, one of the cool things that we can do in pandas is we can get a lot of information about our data frames. And a data frame is the same thing as a table of data or a matrix or however you want to think about it. I'll tend to use the term data frame most of the time, maybe table, but they all mean the same thing. And what we do is we say, hey, I got this object, this data frame object called reseller sales, and I can call the info method on it. And this will provide me a lot of high-level summary information about the data frame, and it's quite handy. So let's take a look at what we get. So the first thing we do is we get the fact that the object is in fact a pandas data frame, which is not surprising. That's the data type. And what we can see here is that we have 60,855 entries. That's the number of rows. And then of course we have a total of 23 columns. And notice of course that Python starts counting from 0, so everything starts counting from 0. And what I can see here are all the different names of the columns in my data frame here. And what's really super important too is I can also get a count of the non-null values. So in this case, what we can see here is for this particular column, product key, we have 60,855 non-null or non-missing values, which is the same number of rows. So this particular column, this particular feature is not missing any data. And what we can see is that if we go up and down the entire length of the output here, we've got no missing data. So that's good. That's not always going to be the case with our data frames in this particular tutorial. So it's one of the things you want to check. Over here, we have the data type. This is the type of data, the data format that Pandas thinks these columns contain. So for example, int64 is just an integer. Object is typically denotes a string, more often than not, some sort of string value. Float 64, that's a decimal point, floating point number, and we can see more strings here. Now notice this. Notice that these are obviously based on the name date columns, but they come in as strings. We're going to take care of that later in the tutorial. So for right now, Pandas just thinks they're strings, and we're okay with that. We say, okay, whatever, because we don't really care right now. And we can also see here that the memory usage for this particular data frame is around 10.7 megabytes, which is nothing at all for a modern laptop. All right, so moving on. What we're going to do here is get some more information about what's going on in the data frame. So one of the things that we might want to do is get a preview of the first 10 rows of data. So I'm going back to my data frame object. I'm using the dot to access it, to actually perform some sort of operation on it. And head gives me the first number of rows. So by default, you give 5. So if I call this, I'll get 5. But I can also change how many rows come back by using the parameter n for the number of rows. In this case, I'm getting back 10. And what we can see here is a preview of 10 rows, 23 columns. And this is super useful for you just to start getting some idea of what's being contained in the data. Now, one of the things that can be a little bit frustrating is that you'll see here are these ... these ellipses. What that tells me is that there's more width to the data frame than it's actually being rendered. And what they're saying is here is, hey, there's some columns that are not being actually shown. And we'll see later on how we can actually subset the number of columns that we want so we can make sure we can just look at the columns that we're interested in and make sure that we always see the data we want and avoid these ellipses, which can be a little bit annoying. Yes, in case you're curious, you can set an option to increase the width of the display of a data frame, but at some point, if you have 100 columns, it's just not practical anymore. Okay, moving on. We're going to go ahead and show the last 10 rows of data here. So I just copy and pasted the code, and I'm going to go ahead and say tail, which is the end of the data frame. And we can see the last 10 rows. And what's super interesting, and we're going to talk more about this later, is you can see this column here doesn't have a label. This is known as the index. And essentially you can think of it by default as being the count of the rows. And you can see we go from 0 all the way up to 60,854, which is of course what we would expect given that Python starts counting from 0. Okay. And you can just look at the tail. Sometimes it's useful to look at the head and the tail both just to make sure there's some consistency going on in the data, but more often than not, you'll probably just use head all by itself. Okay. Now, one of the things that we can do, of course, with our data frames is access individual columns. That's what we're going to do a lot in analytics and data science code. So I'm going to access a column as an attribute, reseller sales, dot sales territory group. Okay, this is a column on our data frame. So if I scroll up, you can see sales territory group right here. So if I run this, what I get is a preview of the data. I get the first 5 rows and the last 5 rows. And what we can see here is in this case, they're all the North American sales territory group. Now, what's super interesting is, of course, is that this is a series object. And we can prove that by simply doing this. What is the type of this code here? I'm just going to highlight it. Control C, Control V. I guess technically that's not right since I'm on a Mac right now. Okay, and you can see here that my object is a series object, just as we described in the slides. Data frames are basically collections of series, right? Series for each of the columns, series for each of the rows, so on and so forth. Now moving on, we can say, hey, are there different ways that we can access our columns? So for example, what we can do is actually provide the square brackets to go into, to index, to select things from the data frame. And we can use a string value here to actually access it. Now you might be wondering why you would use one or the other. And the answer is that Pandas data frames do support column names with spaces, embedded spaces in them. So you can't use this attribute-based method in those cases, but you can use columns with spaces in the names using the string. So in general, I almost always use the string format. I very rarely ever actually use the attribute. That's just the way I roll. Your mileage may vary. But we can see we get exactly the same thing back. Now, what's awesome is that we also have the ability to use something called loc. And loc is a particular attribute that allows you to access your data frames, usually based on some combination of very specific criteria. And let me show you what I mean by that. So reseller sales, actually, let's put a comment in here. Whoa, can't type. Reseller sales. Loc. Okay, so loc is an attribute, and we use the square brackets once again for indexing or slicing and dicing our data frames. And what we need to do is think about this idea of a comma. So what the comma does is says, look, anything before the comma refers to the rows, and everything after the comma refers to the columns. So for example, I could say, hey, give me rows 0 through 5, right? And that will give me the first 5 rows because, you know, usually in Python, for example, what you see here is that you don't include the end index. So it's 0 all the way up to, but not including 5. But more often than not, you typically want to select all of the rows of data, and you can use a colon as a shorthand for that. Okay, and then we can also specify what column we would like by just providing a string. Territory group. And this produces exactly the same output that we've seen before. Oh, let's put a comment in here too, why not? Well, that's not right. Sorry. Told you. That this is... then I'm not going to edit this because I just can't do it. It's too much work. Just call them as a string. There we go. That's what we want. All right, moving on. And let's see here. What we're going to do next is we're going to start using some of the methods on a series object. So the series object is pretty complicated. It's pretty complex. It's got a lot of functionality in it, just like a data frame. This tutorial is only going to scratch the surface. Remember, we're following the proverbial 80-20 rule. So one of the things we can do with series objects is we can also use head and tail on a series object. So working with a series object. So we're going to go ahead and just copy and paste this code so I don't have to type it over and over again. So reseller sales dot head n equals 10. And that works. Whoops. Oh, David, picked the wrong one. Here we go. This is what I want to pick right here. My Grammarly is really super annoying right now, and I apologize for that. There we go. That's what we wanted right there. Okay. So we can call head on a series object. Not surprisingly, we can also call tail on a series object if we would like as well. And they work basically the same. First 10 values, last 10 values of the series. Now, this you don't actually do, in my experience, much often in practice. One of the things that you do a lot on your series objects is actually try and get some descriptive statistics about what's going on in your series, that is your columns in your data. So we're going to go ahead and do working with series objects again. And this particular column here, sales territory group, we know is string data. We saw that earlier. So it's like North America, so on and so forth. So one of the things we might want to do is we might want to do value counts on it. This is a super handy method on your series objects. What it does is it goes through, finds all the unique values in your column and counts them up and gives them back to you. So if I run this, what we can see here is overwhelmingly our data is associated with a North American sales territory group as opposed to Europe or the Pacific. And we see the individual counts here. Now, what we don't see by default is if we had missing data. Now, we know we don't have missing data in our data frame, but if we did, it wouldn't be counted by default. Later on in the tutorial, I will show you how to change the value counts call to also include the count of the missing values, because you often want to know that as well. And that's it for working with the pandas fundamentals. Next up, we're going to explore working with numeric columns. All right, so let's create a new section here. Excuse me. Let's see, working with numeric columns. Whoa, that's not right. Working with numeric columns. Let's try that again. All right. So what we're going to do now is we're going to load up another one of the CSV files. So we're going to load up the products data. And what we get here is a far more interesting output. So we load up our products data frame, we get the info on it, and what we can see here is that we have 606 rows of data, 7 columns, and notice this, not all of them are completely full of information. So this one is full, this one's full, this one is missing over 200 rows, this one's missing over 200 rows, this one's missing over 200 rows, this one's missing 200 rows exactly. So this is a more interesting data frame. More realistic of what you see in the real world. Sometimes your data frames are not completely full of data. So that's really interesting to know. And let's go ahead and take a look at what's going on in the data frame here. So we're going to go ahead and run head. And this time, let's get crazy. Let's run 20. All right. So here are the first 20 rows of data in the products data frame. And notice that we have our various columns here representing the attributes of our products. For example, maybe this would come from a data warehouse or a transactional system or something like that. But what I wanted to show you was this. Notice here you see these little NaNs. This stands for not a number. This is Pandas' default way of showing that you're missing data. So essentially what this is saying is anywhere you see an NaN, you're basically having an empty cell. If you're familiar with databases, this is equal to a null value. So these are the absence of values. And what we can see here is that for some of our product catalog, we're not complete in terms of our data here. And that's totally okay. So moving on. What we're going to do here is, of course, do some tail work here. And what we can see here is, at least at the tail end of the data frame, everything's filled out. You can see here we've got a bunch of mountain bike information, some bottom brackets, not even quite sure what that is, some road bike information, so on and so forth. So what we have here is a mixed bag. Some of the data is missing and some of it's not, as we well know from looking at the info earlier. Now what we can do is start working with our numeric columns. We're going to deal with string columns in a bit, but right now we're going to work with numeric columns. So one of the things that we want to do maybe is to say, hey, let's get some attributes regarding our numeric columns. So for example, we can get the count of non-missing values. So what we can do here is we can go to products, we can go to the standard cost column, and we can ask for the count method by using the count method. And this will return us back the non-missing values by default. So you can see here, we know we have 606 rows, but only 395 come back because we know we're missing values. So this is the number of values that are filled in. Now, if we want to just know how big the series is, the column is, how many particular entries there are available, we can use the size attribute. Whoa, misspelled that. Length of the column. So products, standard cost, dot size. This is an attribute because notice there's no parentheses, and we get back 606, which we know is correct. Now, we can do a lot of more interesting things than just this. For example, we can grab a column of numbers and we can sum them up. The thing to know is that missing values are ignored, which is kind of the behavior you would expect if you think about it. So products, standard cost, sum. I mean, this is not the greatest example in the world, right? A better example would be using like a sales column or something like that, but just roll with it. And we can see here, here's the sum of the non-missing values, the 395 non-missing values in the standard cost column. And we can do other things as well. If you're familiar with SQL or Excel pivot tables, this is all going to be really super familiar for you, to you. Missing values are ignored. And we can do products, standard cost, dot min, which, hey, what's the minimal value? So in our product catalog, the minimum costing thing that we have is around 86 cents. Now we can also, of course, do things like paste this in, and we can do max here. We can paste this in and paste this code in, and we can also do things like get the mean, which is the average. If you're not familiar, mean is just another word for average. And I'm going to put several lines of code on here. So I'm just going to go ahead and do this and then highlight this code and copy it again. And then what we can do is calculate the median. If you're not familiar with the median, this essentially is, think of your column of numbers being sorted in ascending order. And then the value that's right in the middle, the 50th percentile, right in the middle of your sorted column of numeric values, that's the median. And then we can do standard deviation. And if you're not familiar with standard deviation, that's just a way of calculating how spread out are the numeric values in general. And what we can see here is all the various values for the standard cost column. Once again, making note of the fact that missing values are ignored. Okay. So there you go. So we can see here our average value is 434, but the median is 204, which means that we have a little bit of skew in our data. And we'll see this later on in the tutorial when we start visualizing our numeric columns. We can start talking about skew and how we can figure out what's going on there. All right, next up, we can say, look, this is even better. Rather than writing these functions out one at a time, there's this handy dandy function called describe. And what it does is it produces a bunch of summary statistics for you. So if I run this, what you get back is a series object, okay? And what you get here are various calculations, like the count of the non-missing values, 395, we saw that before. The mean, which we saw already. Here's the median. And then we can also see the min value, the max value, the 25th percentile, the 75th percentile, the standard deviation. This is great. The describe function is a handy dandy way to start getting some high level information about what's going on in your numeric columns. And like I said, later on in the tutorial, we'll do some visualizations of your numeric columns. That's even better yet than using summary statistics, but this is a good place to start. Okay, so that was a brief introduction to numeric columns. We're going to revisit this throughout the tutorial, but that's enough to get us started. Next up, what we're going to do is we're going to work with string columns. Okay, and let's see here, what should we talk about? So first up, you need to use something called the str or string accessor. Okay. Once again, missing values are ignored. Good thing to keep in mind. And what we're going to do here is make all the characters or the chars lowercase. Silly example, but what I'm doing is I'm demonstrating some of the built-in string functions that are available on your string columns. There's a tremendous amount of functionality, once again, available to you. ChatGPT or good old school Google will help you out with this if you need more than what we're going to talk about in this video. So what we're going to do is I'm going to create a variable called prodcat lower, and it's going to go from it's going to be sourced from the product category, there you go, Dave, column and str. You need to do this. This tells pandas, hey, I want you to treat this particular column as a string and give me access to all the really cool string functionality that you provide. And Panda says, okay, Dave, what do you want to do? And I said, hey, I want to lowercase this particular string. And then let's go ahead and highlight this code here. And we'll do head on it. Why not? N equals 10. And if I run this, well, not surprisingly, I get not a number, because remember we saw that earlier in the head of the entire data frame, that we're missing some values. And what ends up happening is like, Panda says, look, when you want a lowercase missing string values, I don't know what to do with it, so I'm just going to return back a missing string value. And that might be concerning for you, but don't worry about it. It's exactly the behavior you want. And what we can do here is, of course, go to the tail. And then what we can see here is, oh, okay, yeah, at the end of the data frame, at least we know we've got some string values, and you can see here they are, in fact, lowercased. Now, not surprisingly, if we can lowercase things, we can make our chars uppercase. And by the way, you might be wondering why I'm even bothering with this. And the reason for this is something that's very commonly done when you're working with string data and analytics. You want to normalize the case. This is what's known as case folding. And what this does is allows you to make sure that all of your string values are standardized. Prime example of where you do this all the time in the real world is with addresses, because people tend to, do funky things with addresses, right? They might abbreviate street as capital S, capital T, or they might do capital S, lowercase t, things like that. So when you case fold, when you put them all in the same case, it makes things just a little bit easier for you, especially if you're doing things like text analytics. So what I'm going to do here is I'm going to say, hey, I'm going to make it uppercase instead. And then what I can do here is just tack on my call to tail. And notice what we're doing here. We're going to this particular object, which we know is a series object. This object has an attribute called string and the string accessor on it. And we say, okay, cool. And then we say, oh, on the string, call the upper. And then what that object gets returned, which is a series object, we can then call tail on it. This is what is known as essentially method chaining. And we'll see later on in the tutorial here that there's actually a better way to do method chaining than this. Quite frankly, this kind of style of coding right here, where you have all these dots and you're just chaining all these things together, often makes Python a little obtuse to people that are brand new to programming. Using something called method chaining that we'll see earlier on makes this a lot easier, a lot more intuitive. So we can run this here. Oh, well, that's not going to do much, because notice what I did here. I goofed up. This should be an upper, not lower. So I'm going to go ahead and just pretend like I didn't do that goof. Sorry about that. And then we can do, geez, told you that I'm not editing this. Actually, this is what I want to do. Good Lord. There you go. So notice what I'm doing here is I'm just showing you the functionality of actually storing the results in an object. That's what I wanted to do. My apologies. Okay, there we go. And you can see here, sure enough, they're all capitalized, which is exactly what we would expect. Okay, now one of the things that we can do is, let me just run this real quick, because I want the prodcat lower variable. I'm going to go ahead and grab that, copy it. Okay. Now what we can do also is, let's say that we have our data has been case folded. Let's say it's all been lowercased, which is very common, by the way, in text analytics. It's standard practice just to lowercase all of your text. So maybe you want to capitalize the first letter because you've already case folded everything. So you capitalize the first letter. And what we can do here is we can do prodcat lower. Oops, actually just let me paste that in. And then what we can do here is use the str accessor on it to make sure that we tell pandas that it's a string, and we can call capitalize on it. And then we can do tail n equals 10. And I'm doing tail here because we know that these values are actually filled out, unlike the beginning part of the data frame. And what we can see here is that These used to be all lowercase, and now the first letter is capitalized. So that's a pretty handy function. Once again, prime example of where I've used this in the past is with addresses, right? For example, I lowercase everything, and then I go through and capitalize things. So then the abbreviation for street becomes lowercase s, lowercase t, and then now it becomes capital S, lowercase t. It's a way to help standardize your address data. Now, these are all certainly useful, but there's a lot more that we can do, not surprisingly, with string columns in pandas. So for example, we might want to know, hey, go through the entire column value by value and tell me whether or not it is purely alphabetical. No numbers, nothing like that. So we can return a series of true false values. Got to spell that correctly. False values. There we go. And we can say, hey, we're going to call this series object that I'm going to create is alpha. And what I do is I go to products, product category, str, right? Got to make sure I treat it as a string. And then I can call is alpha on it. And that'll give me back a list of true false values, of Boolean values that says, hey, if it's only alphanumeric, tell me, give me a true. If it's got numbers in it too, if it's alphabetical only, give me a true. Otherwise, give me a false. That's what I meant to say. Well, there's your problem right there. And we can see trues. And if I do head just for grinsies, notice we get back not a number, which makes sense because it makes no sense to be like, well, is it alphanumeric? Well, it's missing data. I have no idea. So that's what the NaN stands for. So we go run the tail here and we go to town. All right. Next up, what we can do here is check to see if things are numeric. So what we do here is I'm just going to copy this code and is numeric, Control C, Control V, and then we do is numeric, not surprisingly. And it's pretty handy if you want to start characterizing what's going on in your string data. Now, we can also do things that are even far more interesting. Generally speaking, these is numeric, is alpha. There's also an is alphanumeric method. They're useful, but what you tend to do most of the time, quite frankly, in my experience, is you want to know certain things about the data. For example, does it start with a particular character? Does it end with particular characters? Does it contain particular characters? Things like that. So we can do that pretty easily. But one thing we need to note is that these things are case sensitive by default. Now, if you know what these are, what I'm about ready to type here in the next comment, this will probably make you sad. So regular expressions are not supported. And if you don't know what regular expressions are, don't worry about it. But if you do, just be aware of that. So we're going to do product subcategory from our products data frame here. And what we're going to do is do the str accessor, and then we're going to say, hey, does it start with these particular characters? RO for road bike, for example. Maybe I'm interested in knowing, hey, which of the columns are actually about road bikes? So I can make it RO, or I can make it road, or whatever it might be. Okay, and notice this is case sensitive though. Case sensitive. This is why, for example, you might do case folding. You might just make everything lowercase so then you don't have to worry about it. But in this case, we're going to work with the case data. And what we can see here are the first 5 values, which come back NaN, not surprisingly. And then we can see, hey, of the last 5 values, the first 2 of the last 5 are not about road bikes, but the last 3 are. Now, not surprisingly, we can also do ends with. And what we're going to do here is this as well. All we do is just change ends with, and we'll say bikes, the string. Okay, the last 5 characters, do they end with B-I-K-E-S, where B is capitalized, true or false? What we can see here is boop, 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 once again. So this is obviously super useful stuff. Now, of course, Even more useful than either of these is, does a string value in a column, value by value in the column, contain some sort of character or set of characters? So what we can do here is copy and paste. And what we can do is contains. And what I'm going to do here is just do space. It could be anything, right? I could be RO, it could be bikes, but I'm going to do space. Another common thing that I do is things like I'm looking for commas, I'm looking for semicolons, I'm looking for pipes, various types of special characters where I'm like trying to parse stuff. So this is a really super useful function. And just run this, and what we can see here is all these guys contain trues, and the first ones come back NaN as we would expect. Now, another common thing that we do is once we've identified what's going on in our columns of string data, is we want to actually replace strings. So for a classic example would be, I want to replace commas with something else if I'm trying to generate a CSV or something like that. I commonly do that. I commonly replace commas with semicolons, and makes my CSVs work a lot easier and better for people who are not necessarily maybe so technically inclined. Now, we're going to do a kind of a contrived example to show you what's going on. And by the way, for those folks that are down with this, regular expressions are supported in this particular method. I'm not going to use them because regular expressions are an entire thing. And if you don't know what they are, don't worry about it. So I'm going to go ahead and go to my product subcategory again. And what I'm going to do is I'm going to say, hey, I would like to replace some data, please. And I'm going to say, hey, I want to replace bikes with bicycles. Why am I doing this? Just to demonstrate to you what you can do. Would I do this in the real world? Probably not. So if I run this, you can see here, road bikes becomes road bicycles. Okay, so you can also replace string values. Now, another thing that's really super handy in analytics when you're working with string data is being able to calculate the length of the individual strings. And I do this all the time. For example, if I have freeform text data that I'm looking at, oftentimes the length of the strings can be very, very useful from an analytics perspective. Take product reviews. Generally speaking, when people hate products, they tend to be pretty verbose when they write their reviews. Typically, when they really, really like a product, what I've seen more often than not is they tend to be shorter. So the length of the strings can actually be quite useful. So get the length of each string in a column or a series. Let's make that a series, in a series. Okay, and how we do that is, once again, I'm just going to go to the product subcategory column, get the string accessor, and I'm going to call len for length. And then what I get back is the lengths of the strings. We see here 10, 10, 10, 15, so on and so forth. Not particularly useful with this particular data set or this particular column, for example, but in general, this is a very super useful thing, especially once again, if you're doing text analytics. Okay, now, one of the things that you often do, as I mentioned before, is call value counts on your string columns. Maybe not so much necessarily on your numeric columns, because usually numeric columns have many, many distinct values in them, but definitely for your strings, because more often than not in business analytics, your string columns, your string series objects are categorical data. So get the counts of distinct values. Well, let's just go ahead and paste that in. Why am I typing? Okay, and then value counts. Now, as I mentioned before, by default, value counts ignores missing values. More often than not, that is not what you want. And in fact, I think the default here is unfortunate from an analytics perspective. So if you want to count the missing values, you have to use the drop NA parameter, and you set it to false. It's true by default. And if I run this, okay, what did I do here? Oh, my goodness, my bad. You don't actually need the string accessor for value counts. My apologies. There you go. All right, and notice at the very top, the most popular category, the most popular distinct value in the product subcategory column is missing data at 209 entries. And then what we can see here are all the other unique values: locks, chains, pedals, shorts, road frames, road bikes, so on and so forth. Okay, so this right here is super useful. I use this particular code all the time in my real world analytics. And that's going to be it right now for a quick introduction to working with string columns. We're going to see more examples of working with string columns throughout this tutorial. Okay, I'm going to need some more cells here. So beep, 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 beep. And scroll back up. Now let's start working with datetime columns. Hashtag working with datetime columns. Because as I mentioned at the very beginning of the notebook section here of the tutorial, we obviously have 3 columns that are date times, but right now they're being represented as strings because that's all pandas knows, right? So what we can do is define a Python list that actually contains the names of our date columns. So we have order date in our data, we have due date, and we have ship date. These are the names of our date columns. And then what we're going to do now is we're going to actually reload the reseller sales data from the CSV, but we're going to tell the read CSV function when you load in the data, hey, these are actual date columns. These guys right here are our date columns. And here's the format that they're in. Please load them as Python datetime objects so that we can do cool datetime stuff with them. Otherwise, if they're strings, we can't really do any of that. So load the reseller sales data. And I'm just going to go overwrite the original object here. Reseller sales, excuse me. Read CSV. And of course, we have a reseller sales.csv file. And here's the thing. We need to use the parse dates parameter. Parse dates parameter. And what we do is we just pass it in our handy dandy list. And that tells it which of the columns that it's loading in are in fact actually date times. And then we also need, we don't have to do this, but it's a good idea to specify the date format. And %m says, look, my date strings are starting with months, because this is an American format. And then I got the date, and then I have the year as 2 digits. So I use lowercase m, lowercase d, and lowercase y to denote the digits, and they're all separated by forward slashes. Pretty standard American style way to represent dates as a string. Unfortunately, not the best way to do it, but extremely common. And what we can do here is reseller sales.info. And if I run this code and I scroll back down, notice that everything looks the same as before, except for now I have datetime 64s. This is what I want. This means that these columns are now legit date times, and I can do very interesting things with them. So let's talk about what we can do with date times. Oh, and you know, before we do that, let's get a head going on here. And let's just scroll all the way to the over here. And notice that originally these came in as strings, and they came in as 12/29/10. Because those were the string values. But notice now that these are in a more optimal format. So we have the year as a 4-digit number, and then dash the month, dash the date. Okay, this is pretty standard. This is the way we really like to see dates, generally speaking. And this, by the way, is just a representation for humans. Deep down inside in the bowels of the computer, this is actually a number. It's not really something that we would recognize as humans. Okay. So now that I've got a head going on, let's go ahead and start working with some datetime data. Now, not surprisingly, if we need a string accessor, it makes sense that we're going to need a datetime accessor as well, the DT accessor to be specific. Note, whoa, year is an attribute. Okay, so what I can do here is I can say, look, I'm going to create a new series object, which I'm calling order_year, which is being created from the reseller sales DataFrames order date column. I use the accessor .dt to tell pandas, hey, this column should be treated as a date time, please. And then I'm going to access the year. And just to print this out for you, order year. And what we can see here, sure enough, here is the year as integer values. You can see here they're in 32s. This is a series object of all the various years. It's essentially plucked out the year value from the dates, the date times, and then just provide me a column of that. And this is super, super useful. We do this all the time in real world analytics. In fact, you typically, when you're doing advanced analytics in particular, you never want to use raw date times. You actually want to extract out the pieces of the dates like you see here. So continuing with this theme, let's pull out the months. So I'm not even going to bother with creating an object just to show you what's going on here. And we can see here, we see the months as a number. But we don't have to stop there. We can actually say, look, you know what? Maybe I want to actually work with the string values instead. And there's actually some really good reasons to do that. Not the least of which is if you actually work with the months using their names, they'll automatically be treated in many circumstances as categorical data, which is exactly what you want. The only downside is that the names of the months in English are not correct in terms of alphabetical order, right? January is the first month of the year, but alphabetically, it's not the first position when you sort all of the month names. That's something we will talk about later on. But for right now, let's just talk about how we can get the month names here. So what we can do here is copy and paste this code. And what I'm going to use is the month name method. And it's a method because I got, if no other reason, because I'm using parentheses to call it. So if I run this, I get the month names, the full month names, December, November, that sort of thing. Super, super useful. Often this is what I'm doing because I actually need months to be categorical, not numeric, in most of my advanced analytics. So this is super handy. Now, of course, we can also access the day as a number here. So I'm going to copy and paste this in using day. And we get the days. These all just happen to be the 29th for some reason. If we go in the middle there, you can see other values as well. So that gives me all the day values as numbers. And I don't have to stop there. I can actually get the day names as well. So I can go ahead and do day name, the method with the parentheses on it. And notice I get the full names. Yes, you can also abbreviate these just to the first 3 letters of the month and the first 3 letters of the weekdays, weekday names if you'd like as well. But here's something that's really cool. I love this one. This is so cool. Is leap year. How cool is that? It'll give you back a series of true and false values to tell you whether or not the date was actually in a leap year. Awesome stuff. Now, going on, we can also do things like, hey, is month start? Is the date time in question the first day of the month? Trues and falses. Now, of course, we can also say, simultaneously, I'm going to go ahead and just copy this, paste it down. Is month end? Super awesome. And like I said, this is just the tip of the iceberg of what you can do with datetime data using pandas. ChatGPT, old school Google will help you out. We're going to do some more stuff with date times throughout this tutorial, but this is just enough to get us started. Okay, let's have some fun. Well, actually, all of this is fun. At least I hope you think so anyway. All right, so let's visualize some columns here. And what we're going to mostly look at are some very basic visualizations for both our numeric and string or categorical columns. So first up, let's talk about visualizing our numeric columns, which is really, really super handy. So to refresh ourselves, let's get some summary statistics for reseller sales. Actually, we're not refreshing. This is actually brand new, if I recall. So we're going to take a look at the sales amount column of the reseller sales data frame, which had like over 60,000 rows of data. And as we know, we can use the handy dandy describe function on it and run it. And let's take a look at this real quick, just so we can understand what's going on. We can see here, we got our count, right? 60,855. The mean or the average sales amount in this particular data frame is $1,322. But notice this, the median, and once again, the median is take your column of numbers, sort it in ascending order, go to the very middle of the column, and what value is there? the 50th percentile. And notice here it's 461. The average is almost 3 times as high as the median. Now here's the thing, both the average and the median are ways of characterizing what a quote unquote typical value is. So if they're off by a lot, what that tells you is that your distribution is kind of skewed. And this is also borne out by this idea of the standard deviation, which is quite high at over $2,100. But this is all a bit abstract. So what's really nice is to actually visualize this using a histogram. Okay. Reseller. Oh, actually, I should just copy and paste the code. What am I doing here? Why do I always have to make things so difficult? All right. So we're going to say, hey, pandas, we want to go to this particular column and we would like to plot it. We'd like to create a visualization for it. And Panda says, cool, Dave, what kind of visualization would you like to create? And I'll say, hey, I would like to create a histogram, which is the hist method. And if I run this, I get a nice little histogram. And this is super useful because what it shows us is why the mean and the median, or the 50th percentile, are so wildly different in terms of describing what the typical value is. Because what you can see here is obviously the vast majority of my sales amounts here are below, let's call this 2,500, right? This looks like halfway between $5,000 and zero. So this is $0 to $2,500. So the vast majority of my sales are actually at the low end. But notice I've got this long tail effect. And long tails like this tend to make your average higher because the mean or the average is calculated using every value. So this is why we're seeing some skew here, because we have a small number of big orders that is pulling up our mean calculation, and the median is telling us, well, actually most of your sales are actually quite a bit lower than that. Now we can manipulate the appearance of our histograms to make it a little bit more useful. So let's go ahead and copy and paste this code down here, and let's go ahead and set the bins. So real quickly, if you're not familiar with histograms, these bars represent bins. So for example, the first bin here is from 0 to 2,500. And this looks like to be about 2,500 to 5,000-ish, right? So these are the bins. And these bins are calculated automatically when you just call hist. They try and do a good job, but in general, sometimes it's hit or miss. So what you can do is you can actually specify the number of bins that you would like. And what this allows you to do is actually control how many bins you have so you get a more fine-grained look at the data. So let's run this and let me show you what's going on here. And notice now that I have more bars, more bins, and it allows me to understand a little bit more about what's going on in terms of the distribution, the counts of the individual values in the sales amount column. And what we can clearly see, of course, is that it's still skewed to the lower end. But if you add a few more bins, you can say, okay, well, how does it work? I get more of a gradual stair-step kind of shape to it. The more bins that I add, the more that looks like. So let's make this 50 for grinsies. And what we can see here is more steps and that kind of thing. You can just change the value. And that's generally what you do when you're working with histograms, is you change the bin size and look at it and see if it helps you understand what's going on. Now, a good complementary visualization to your histogram is something known as a box plot. And let's go ahead and just copy paste code again. Why not? As a box plot. And what we're going to do here is we're just going to call box. No parameter here. And I don't have time to go through how to actually read one of these. You can certainly Google it or ask ChatGPT to explain it to you. But in general, what's super interesting is that this main box in a box plot tries to tell you where your center of gravity is, if you will, of your data. What is the middle 50% of your data, essentially, is what this box represents. And these circles actually represent outliers. So there's a very specific calculation that is used, a standardized calculation, to define regular values, quote unquote, versus outliers. And what we can see here is so many outliers, which once again matches what the descriptive statistics were telling us at a high level, which is our data is skewed. These outliers are driving up the mean or the average value vis-a-vis where the data is actually centrally located. So this is why oftentimes we want to look at both the mean and the median to understand what's going on. And of course, if we visualize, it's a lot more powerful than just looking at summary statistic output. Okay. So let's move on to start visualizing some of our categorical or string columns. Okay, so we're going to do prod cat counts. And I'm going to source this from products, product category, and I'm going to call value counts on it. And of course, because we're awesome, we're going to say, hey, drop in A equals false. We want to count up the missing values as well. And we know what this looks like already. So we can do this. And say, okay, cool. Our product categories, 209 are missing, components, bikes, clothing, accessories. So this gives us our individual categories and then the counts relative in the data set, which is cool. But it's often better to visualize this. So we can plot a bar chart. And then what we get is a nice handy dandy bar chart. And we can see here, which is nice. But typically when we're looking at values like this, trying to understand like rank ordering of which one occurs more often than the others, we typically want to use a horizontal bar chart because that's just a good visualization for most humans to use. So I'm going to go ahead and put this in here, and what we're going to do is bar H for horizontal. So let's see here, create a horizontal bar chart of unique values. Okay. And there, voila, we get a bar chart. Now, here's the thing. I don't want to get all theoretical on you, but this is actually not optimal. Typically, you want this sorted in descending order, not ascending order, because of human perception, we just look at things better that way. So what we can do here is just copy and paste this code. And now what we're going to do is actually chain in a call to sort values. Okay, so let's see what's going on here. So here's my original series object here, right? Which is just the counts, which came from value counts. On this particular series object, I'm saying, hey, sort your values and then plot those sorted values using a horizontal bar chart. That's what this code does. And if I run this, voila. This is what is typically optimal for most humans. Handy dandy, super easy peasy, awesome. Okay, we're going to talk a lot more about data visualization in my next video in this series. And I'm going to be using a library called Plot9 because quite frankly, as cool as Pandas is in terms of its visualization, it's not super awesome. Let's put it that way. Plot9 is super awesome. So awesome, I would call it the mighty Plot9 library. So stay tuned for that. And I'll talk a lot more about how you can visually analyze your data using Plot9 in that video. So next up, what we're going to do is we're going to talk about indexes. So I mentioned indexes earlier. So let's talk about indexes here. So mark down indexes. Now, if you're not familiar with indexes, because maybe you haven't ever worked with databases or something like that, the easiest way to think about it is a piece of data that is included in just about every Pandas object, and it's trying to provide a unique identifier for each row. So the easiest way to start is just to think about a very simple case. And let's look at our product cat counts. Let's put a comment here. Check out the index. Okay, so here's the thing. As it turns out, these are the actual values of the series object. These are the numbers. This over here is actually the index. It's not, technically, if you want to think about it this way, if you want to think about this as a table, this is the only column in the table. And this is the index. This is like metadata, additional data. And series objects will store both indexes and values. Just like we saw earlier, DataFrames also have all the columns, and then they also have an index as well. Now, indexes are super useful in many situations because it allows you just to pluck out exactly what you want. That being said, I will be completely honest. In general, in analytics, you don't spend a lot of time working with indexes. And in fact, you want to get rid of them in many, many circumstances, which we will see later on in this tutorial. But let's just talk about how we can work with indexes as is. So let's say we're going to indexing a series object directly. Okay. And note, this code returns a single value. Not a series object, it returns a single value. So prod cat counts, and I'm going to access bikes. And now a series object, when it sees this code, says, oh, Dave wants to go to the index and access a specific row from the series object, or a specific cell, if you will, based on the index name. And what's going to happen is it's going to go through all of the indexes and say, Dave wants this one, and it's just going to return back the single value of 125, which is basically kind of what you would expect. Now you can also indexing using loc as well. So we can do prod cat counts dot loc, and then we can just pass in bikes, and we get back 125, a single value, just like what we saw before. So that's another option. I mean, in general, I'll be completely honest, I don't use loc very often when I'm writing code for analytics, and you'll see that as we move on through the tutorial and we start doing joins and things like that. We just don't really, in the query method, we just don't use loc. I just don't use loc all that often, but it is there in case you want it. Now we can do even more interesting things. We can create a list object, and we can fill it with index values. And then we can use this, use the list for indexing. Note, this code is going to return back a series object. So prod cat counts, and what we do is we just pass in our indexes list. And what's going to happen is we're going to get back the values for bikes and clothing. But since we're actually asking for more than one value simultaneously, what we get back is a brand new series object. And this series object only contains two things, bikes and clothing and the associated values. These are the actual numeric values. And this is the index. The index is for the brand new series object that's created from us doing indexing. Okay, the last thing that we're going to cover about indexes right now is that most of the time, what you're going to see in the real world when you load up entire data frames and you're working with indexes is just an arbitrary numeric index. So let me show you an example of that using the sales amount column. So we can go to reseller sales, sales amount column, which is numeric column, and then we can just ask for the index attribute. Now, if I run this, what I get back is a specific type of pandas object known as a range index. That's not really what we care about. What we really care about is this definition right here. It says, look, the index for the sales amount column ranges from 0 up to 6,855, but does not include 60,855 because, it's pandas in Python. And then we have a step of 1. So we go to 0, 1, 2, 3, 4, so on and so forth, all the way up to, but not including 60,855, which essentially is just a unique identifier just based on the row count and the row position. That's all it is. And by default, that's typically what you see most of the time in your pandas data frames. And usually you're not even working with the indexes at all. Okay, next up, we need to start filtering our data frames, because oftentimes when we're working with tables of data, especially for various types of advanced analytics scenarios, we don't want all the rows. So let's figure out how we can get to the rows exactly that we want. So first up, let's go ahead and set up our markdown here. Filtering data frames. Oops, well, that's not right. Told you. Raw and unfiltered. There we go. Okay. So what we're going to do is we're going to load the reseller's data frame. And to put some of this in context for the remainder of the tutorial, we're going to do a hypothetical contrived data analysis example. It's going to be extremely simple, but it will show you some of the 80-20 features of pandas working with tables of data. So we're going to have our resellers, and we're going to ask pandas to load it for us, and it's in resellers.csv. And of course, I can then call info on it. And what we can see here is the output. So we have 701 rows. And we can see here that we're missing some data for address line 2, but everything else is completely filled out in terms of the data in each column. And that kind of makes some sense, right? That address line 2 would be sparsely populated. Totally understandable. Okay, so here's our data frame that we can work with. And what we're going to do is we're going to pretend, and this is going to sound shocking to you, I know, that AdventureWorks would like to increase their revenue. The CEO has a goal of increasing revenue by X amount. So one of the things that you want to figure out is, hey, are our resellers, which is one of our primary channels for making revenue at AdventureWorks, is there anything we can learn about our resellers that might help us achieve the goal? So one of the things we're going to look at is the annual revenue of our resellers, just to start characterizing what's going on. Okay, so not surprisingly, we can go to the resellers data frame. We can access the annual revenue column here. And then we can do describe. Let's get some summary statistics on this. And what we can see is some summary statistics. And on average, our resellers have about $158,000 US per year in sales. But what we can see here is the distribution. The 50%, the median, is about 150K, which means that we're a little bit skewed to the high end, but not by a lot, because when the 50th percentile or the median and the mean are pretty close, that's usually a sign that you have a pretty even distribution. Not guaranteed, but it's reasonable at this high level. So not surprisingly, one of the things we probably want to do is start characterizing our high revenue resellers, because what we might want to do is tell our business development folks or our salespeople, hey, these are the kinds of businesses we want. Go out and find more of them. So let's say we're going to look at basically anything above the median. We could use the mean, but the median's close enough, so we'll just go ahead and use the median. So what we want to do is we want to concentrate on those resellers that are making 150K or more in revenue. So one of the things that we will do is we'll create what's known as a mask. And we've talked about this before, but essentially a mask is a collection of true-false values that allows us to select things that we want and unselect things that we don't want. So for example, we can create a revenue mask object, and we can say this is defined as a collection of true-false values where the annual revenue column of the resellers data frame is greater than or equal to 150,000 a year. Now, if I run this and output it to the screen here, it'll make a lot more sense. So what happens is that this logic goes through every value of annual revenue, all 701 values, checks each one to see if it's greater than or equal to 150,000, and returns back false if it's not, true if it is. And what we can see here is we get back an object here that is just a bunch of true false values. And if we want to, we can figure out, okay, what is the type of the revenue mask? And it's a series object. Not surprisingly, right? So it's a column of true false values, and in pandas, that's usually a series. So there you go. So we have a series object called revenue mask of true and false values. True are the rows that we want to keep, and false are the ones that we do not want to keep. Now we can also do some high-level analysis on this. So we can say, hey, revenue mask, let's do your value counts. And what this is going to do is get the true/false value counts. Now if I run this, well, of course you have to spell it correctly, Dave. There you go. Revenue mask. There you go. So out of our 701, we have 396 are true, which, okay, it looks pretty good. Sounds pretty good, right? And that aligns pretty well. I mean, that's roughly 50%, so great. So moving on, what we can do is say, okay, what are some other aspects of our resellers that we might want to care about? Revenue is obviously one of them. Another thing might be the number of employees. That might be another characteristic of resellers that can help us achieve our AdventureWorks revenue goals. So we can create a mask for employees as well. So let's create let's actually explore that a little bit. So let's get summary stats for the number employees column. Resellers, number employees, describe. If you can't tell, I love the describe method on my numeric columns. And what we can see here is, on average, our resellers have about 40 employees, but the 50th percentile, the median, is 35, which tells us that we're a little bit skewed to the higher end. So we can just use the median again. There's nothing wrong with that, to actually define a mask. So the interesting resellers that we care about will have true values for this employee mask. Okay, employee mask. We'll create a new series object here by going to the resellers data frame, accessing the number employees column, and then checking to see if it's greater than or equal to 35. And then we can also just get the true false counts. Value counts. If you can't tell, like value counts a lot as well. I use it all the time. And we can see here 352, 349, about a 50-50 split, which is exactly what we'd expect with a median, using the median to filter these guys. Okay, now here's the cool thing. Now, as mentioned previously in the series, Python will treat true as 1 and false as 0. So you can actually do math with these masks if you want. So for example, you could do employee mask sum, and it'll give you back 352, which is the sum of all the true values. So that's another thing you can keep in mind sometimes as well. Treating true and false as 1s and 0s can be quite handy, like using sum, for example. Okay, so let's say that we're interested in filtering down our entire resellers data frame. We want to filter down the 701 rows to a smaller subset where the number of employees is greater than or equal to 35 and the revenue is greater than or equal to 150K. So we can do that pretty easily now that we have our masks. Filter the resellers using the masks. And let's just call these large resellers. So this will be the filter down data frame, starting with the original resellers data frame, where only returning back the rows where employee mask is true, that is, employees are greater than or equal to 35, and simultaneously the revenue mask is true. So give me only the rows of resellers with more than or equal to 35 employees and more than or equal to 150K in revenue. And then what we can do is get the info on this. And if I run this, we can see here, out of the 751 original resellers, only 352 meet these criteria. So that makes some sense. About half, which is not bad because if you think about it, it makes total sense because since we're using the median for both, you would expect it to be about approximately half the entries. And sure enough, that's what we're talking about here. All right. So now here's the thing. You don't actually have to create these dedicated mask objects if you don't want to. You can use what are known as inline masks. Well, I don't know if that's what Pythonistas call them. That's what I call them. So there you go. So we can say, okay, I'm going to go ahead and filter down my resellers data frame. I'm not going to create an object because I'm just demonstrating what's possible. Now, what I need to do is to make sure everything works correctly when I use inline masks is I want to wrap all of my logical conditions, all of my filters in parentheses. So I know I'm going to have two. So I'm going to have two sets of parentheses, and I'm going to go ahead and AND them together. And this is how I literally build my code, by the way. I build it up step by step because it is easy to mess this stuff up and you get weird results. So if this seems silly, it's not. I've been coding for decades. Trust me, do whatever you can to make sure you don't make bugs. Okay, so we're going to go to the resellers data frame and we're going to say, hey, the annual revenue, remember, is supposed to be greater than or equal to 150K. Sweet. Oh, that's 15,000. There we go, 150K. Almost made a bug there. And I can just go ahead and copy this code, Control C. And then what I'm going to do is just paste it in over here. And then I'm going to change this to be 35. And then make this number employees. And if I run this, we'll get a preview of what's going on. Okay, and what we can see here is the first 5 rows and the last 5 rows. And so we have 352 rows, which is exactly what we saw before. And if we go over here, we can see, you know, first 5 rows are from Australia and the last rows are from the United States. Okay, cool. You can certainly do this. I would caution you to avoid it if you can. It is error prone. If worse comes to worse, creating these mask objects allows you to reuse them, and it also makes your code a lot simpler, so it's less bug prone. But you can write your code this way if you prefer. It is 100% legal, even though I would say, don't do it that way. It's bug intensive. Okay, so we can also use loc as well. So loc is a way to access data frames. It's a way to filter them down. To be honest with you, I don't use loc all that much. I think I've said that before. But I'm going to show you anyway. So we go to resellers or data frame, and we go to loc. And then we say, okay, do the employee mask and the revenue mask. And then I want all the columns. Revenue mask, Dave, don't get excited. There we go. And you can see here, 352 rows, 14 columns, just like we saw before. So you can certainly use loc to filter, although I will admit I don't do it very often. And of course, you can, if you want, put inline masks inside of, sorry, my Grammarly there. Probably should have shut that off. My apologies. Okay, so we can use loc and we can use inline masks. So all I'm doing is I'm just copying and pasting code to show you how you can do this. So I'm just going to grab the part in here. And instead of using the masks, I can write everything inline. Now, as you can see, my code's getting uglier and uglier. And what I'm going to show you at the end of this particular chapter of the video is how to use something called the query method, which makes things so much better. But I'm going to show you all the various options at your disposal, including the ones that are suboptimal. This is definitely suboptimal, I would say. Okay. Now, great. So we're saying, look, the coolest resellers that we have in terms of generating revenue tend to have 35 or more employees. We expect them to make more, 150 grand or more per year, which is kind of cool in terms of revenue. But let's talk about where they're located. So where should our sales folks, where should our business development folks focus their energy? And let's say, for example, we do a lot of remote because we're VentureWorks, we're not that big. So we do a lot of phone calls and Zooms and that sort of thing. So let's take a look at where our resellers are located. So get the counts of resellers by country. Spell that correctly. There we go. So we go to the resellers data frame. We access country region name. And, value counts once again. Okay. And what we can see here is VentureWorks is heavily invested in the North American market. So we have some presence in Australia, some presence in the EU and UK, but mostly, overwhelmingly, it's in the US and Canada. So makes sense that we say, look, hey, resellers that are in US and Canada that have over 35 employees, they're based on our data, they seem like they're going to be a good fit for us. So focus your sales and business development efforts there. So what we can do is we can create a country mask. Whoa. Okay, I'm going to call this country mask 1 because obviously I've got something better in store for you than what you see here. Okay, so here's our mask. So I'm going to have a logical OR in place because my country mask is going to be true when country region name is either the value of Canada or it happens to be the value of the United States. So we go to the resellers, we access country region name, and we say, hey, is the country region name equal to Canada? And if it is, that's great, give me true. And if it's not, check this other value. And this other value is going to be United States. Okay. Let me double check that. That looks pretty good. Let's go ahead and do our country mask 1. And not surprisingly, we're going to look at value counts. And if I run this, notice I get 541, which is the sum of these two values here, and then 160 falses, which is the sum of the last 4 values. Okay, sweet. So I wrote that code correctly with no bugs. Now, as we can see, this code is getting really, really long. And of course, you can do things like, break it out over multiple lines to make it a little bit more readable, excuse me. But overall, it's still error prone, writing all this code. So here's another way to do this. So what we're going to do is we're going to create a list of countries. Countries, yes. So we're going to go ahead and call this countries. Whoop, that's not even a word. Here we go, countries. And it's going to be a list of Canada and United States. Okay. Now we can filter resellers using the list like this. So we can say, create a mask using the list. That's what I meant. Sorry about that. Okay, so we're going to create a mask, and we're going to call this, surprisingly enough, country mask 2. And how we're going to populate it is we're going to go to the resellers data frame. We're going to access the country region name column, and we're going to say, hey, is in countries. This is great. This is functionally equivalent to this, because is in essentially says, look, is the value one of these in the list, which is essentially just a bunch of logical ORs. Is it Canada or United States? Return true, otherwise return false. And what is nice about using this syntax is that I can just add more and more countries. So for example, I could add, let's say, Mexico. And it would work just fine. So this code is actually, I would say, not only less typing, it's also much less prone to errors. So this is the kind of thing I tend to do a lot. So I'm going to copy this and get my value counts out of it. Value counts, excuse me. I'm going to run this. And what did I do wrong? So usually what you want to do is country region column. So what I saw earlier, usually when you see errors like this in your Jupyter notebooks, you typically want to scroll all the way down to the bottom because this usually gives you the most information. This is a stack trace and it's kind of hard to follow most of the time. Okay. And there we go. 541, 160, exactly what you expect. Now, we don't actually have to do it this way. Actually, let's do this. So we're going to go ahead and copy and paste this code using a list. And then what I'm going to do is I'm just going to create an inline list right here. I mean, these two are functionally equivalent. The great thing about creating an explicit list object is that you can reuse it over and over again. And what I tend to find is that's pretty handy. So yes, you could certainly write your code like this, but I typically write it more like this right here, generally speaking. Well, actually, that's a bit of a lie. When I show you the query method, that's actually what I use most of the time. Okay, so moving on. So now we can filter down our data frame. Filter resellers based on country mask. Okay, and we can say country resellers. I'm just going to create a new object. It's going to be a data frame of my filter down resellers data frame. If I could spell, there we go. And actually, I don't need that. I'm going to use country mask 2. And then country resellers. All right. And what we can see here is I get back 541 rows, which is what I expected. And we can see the first 5 rows and the last 5 rows and all the stuff in the middle is ellipsed out. And what we can see here is, sure enough, the first 5 rows correspond to Canada and the last rows correspond to the United States. So all that looks pretty good. Now what we want to do is actually combine all these things, because remember, we're trying to filter down to the resellers that we think are going to be very attractive for our sales and business development folks to go after. So we're going to go ahead and use all the masks for filtering. And what we're going to call these is, well, I'm not even going to create a data frame. I'm just going to show you in line here. Oh, actually, you know what? Let's call this, let's overwrite the other one, large resellers. Let's fix this. So resellers are going to be a revenue mask and our employee mask and our country mask too. And this is great. So if I run this, I get my object back. It's not a lot of fun. So let's get some output. All right. So notice now 269 rows. So when I put all of those filtering criteria down, I go from 701 initial rows down to 269. And these 269 are the way we can characterize, this is what, or segment, this is another term that we use, segmenting our resellers to the ones that are most desirable for our sales and business development folks to go after. Okay. All right, moving on. We can certainly do this with inline masks as well. So let's see what that code looks like, just to convince you that you don't want to do it this way. And so I don't have to type it all out. I'm going to go copy and paste some code here. So what I'm going to do is I'm going to go up here and I'm going to grab this one right here. Oop, I didn't grab the R. I'll probably forget that, so might as well copy it all. Boop, 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 boop. So we're going to come down here. We're going to say, hey, resellers. We're going to go ahead and do this. And we're going to wrap this in parentheses because that's a good way to save our sanity. And if I run this, of course, I'm filtering down to the 541 rows for the US and Canada. But we also know that we were interested in some other stuff as well. Right? So we wanted our revenue mask. So we wanted resellers, annual revenue is greater than or equal to 150,000. That was our first criteria. So I'm just going to copy paste this, Control C, Control V, boop, and then number of employees greater than or equal to 35. And of course, to demonstrate the point, bug, fixed it, and now 269. So this is great. So this will work exactly the same. But notice how hairy this is getting. Now, of course, you can once again break it across multiple lines, but this is error prone and time consuming. So there is a better way. And I've mentioned it a couple of times, and now we're going to talk about the query method. And the query method essentially allows you to define your logical masks directly as string values that get interpreted by the query method. And that's a bit abstract, so let's see it in action. So use the query method to implement the revenue mask. Okay, we're just going to start small. We're going to crawl before we walk and walk before we run. So resellers, that's our data frame, query. And query can take a string value. And the string value is where we defined our logical conditions for our masks. So we say, hey, only return me back the rows from the reseller's data frame where the annual revenue is greater than 150K. And if I run this, 396 rows, that looks pretty good. Now, if you're familiar at all with structured query language or SQL, then this is going to be very, very familiar to you. This essentially is what is known as a where clause. It's a filtering condition. If you think about if you're more familiar with Microsoft Excel, and you think about what you do with the filtering logic of a table in Excel, this is kind of like the textual representation. So for example, in Excel, you would actually go to the annual revenue column. You would click on the filter for the column, and then you would select a numeric filter of greater than or equal to 250 grand. Pretty much the same thing conceptually. Now, what's awesome is that we can start mixing and matching strings here to filter down our data frame. So I'm going to go ahead and copy and paste this, implement the first two masks. And what I can say here is, hey, I want that filter, and I can also use the ampersand here, but let's use human English for a second. Human English. Natural language, excuse me. Okay. So then once again, we can say, hey, implement our two things simultaneously, and we get back 352 rows, but we don't have to stop there, right? We can copy and paste this. And now we can add in, and I'm going to use the and symbols here just to keep things a little bit simpler. And then we can add in our country filters. Okay, so we need country region name is equal to, now since we're embedded here, I need to use double quotes, Canada. So that's one. Or, so I could use or I could use the pipe, country region name. Double quote, United States. All right, let's take a look at that, make sure it all kind of makes sense. Annual revenue, and. Cool. Now I can run this and I get back 269 rows, which is exactly what we would expect. So if I go back up here, 269, yay. So this is a little bit easier to write. Now, unfortunately, of course, things get a little hairy. Things get a little bit long. So you can break this up across multiple lines using this syntax. Notice here I'm putting a space before and after my ampersand here. And then I can just move down, and what happens is behind the scenes is these two strings get concatenated by query and automatically. And if I run this, I get back exactly the same thing. So I'm breaking it out across multiple lines. It's a little less typing, but it's still pretty ugly and it's still bug prone. So what we can do here is actually, let's say, make this all the masks for our comment here. And I can just highlight this code. Control C, Control V if you're on Windows, Command otherwise if you're on Mac like I am right now. And what we can do is we can say, hey, country region name in. This is like the is-in method that we saw earlier. So we can create a list of values here, which makes the code a lot more clean and a lot less error prone. Okay. So we can say, hey, is my annual revenue greater than or equal to 150K? And is the number of employees greater than or equal to 35? And is the country region name in the list of Canada or United States? And if I run this, 269, exactly what we would expect. My OCD is flaring up, so I'm going to go back here and remove the space here. Sorry about that. Okay. So we've got a lot of options with our query function. It's super, super awesome. Now, one of the things that I use this for a lot is not only is defining these conditions like we see, but also something I use a lot is saying, look, give me everything in the data frame except where a column might be one of a particular list of values. And that's a bit abstract, so let me just show you with a contrived example here. So I use this all the time. Not in. Not in. So Australia, did I spell that correctly? Australia, I believe so. Australia, France, Germany. Again, this is a contrived example to be sure. United Kingdom. Now, if I run this, I should get back 269 again, 269. Okay. I use this a lot. This is really super handy stuff. So generally speaking, as I mentioned earlier, I almost never create masks from scratch. Most of the time I'm using the query method. It's super awesome, super handy, super useful. And basically everything you think that you would normally put in a mask, like we saw earlier, you just write out in your query and run it, and it's great. Now, one last thing that I want to show you too, to make your code a little bit easier, is that you can chain queries. So you could take this code, for example, like this. Okay, Dave didn't do that correctly. Hold on now. Boop, boop, boop. There we go. So I'm querying it, and that returns back a data frame. So the first query returns back a data frame only where the rows from the original reseller's data frame are greater than or equal to 150K for revenue and greater than or equal to 35 for the number of employees. So this returns a data frame that's filtered down for these two conditions only. And then what I can do is then query that data frame and then apply this particular set of awesomeness to it. And if I run these, and I did make a bug, which I did, let me fix what's going on here. Oh, I did not do that correctly. So query. There we go. 269 rows. Now, I'm going to show you later on how to actually use method chaining syntax in Python to make this a little bit more readable. This is kind of a pain in the butt to write it like this. But what you can do is you can query your queries, and then that allows you to break out your logic into smaller strings like this, which is nice because it makes it far less likely that you're going to write a bug. And logic bugs like this are really, really insidious. They're very, very hard to find a lot of times, and they're very hard to debug. So anything that you can do to make your code more robust and easier to understand is probably going to be a good idea. All right, now we're ready to move on to some really, really cool stuff, and that is mutating data using assign. So we're going to do a couple things in this section of the video. We're going to not only talk about mutating data with assign, but we're also going to talk about the method chaining syntax that you can use to make your code a lot more readable. So first up, let's take a look at reseller sales. N equals 10, let's say, on the head here. Okay, so we've got a bunch of different columns here, but one of the most interesting that we have is the sales amount and the total product cost. Now, there are many ways to define things like revenue and profit and all that kind of thing. One of the things that we want to do is understand the relative profitability of our largest resellers to continue along with this analysis example. So what we could do is we could create a new column on our data frame, which is the sales amount minus the total product cost. And we'll call that profit. It's probably not technically correct, but for the purpose of this video, it's close enough. So there's a couple of different ways we can do that. The best way to do that, according to the pandas team, is to use the assign statement. So we're going to use the assign method of DataFrames. And what we're going to do is use that and some lambdas to create a new column. So we're going to use a lambda for data wrangling. And if you're not familiar with the term data wrangling, it essentially means all the things that you need to do to acquire, clean, and prepare your data for analytics. So a prime example in data science is what's known as feature engineering, or creating columns of data or features that help your machine learning models, for example, perform better. So let's talk about reseller sales, wrangled. And we're going to go ahead and use a special syntax here. So notice I'm using parentheses. In this particular context, this tells Python, hey, I would like to do method chaining. So everything within these parentheses, consider as being one logical code block, essentially. And Python says, okay, Dave, what do you want to do? And I say, well, Python, I would like to start with reseller sales, please. And I'm just going to go ahead and keep it right here. And then I'm going to indent 1, 2, 3. And I'm going to do a dot. And this dot is a method call on the reseller sales object. And in particular, I'm going to be using the assign method. Hey, pandas, go to this data frame. I'd like to start doing a bunch of method chaining, please. First method in the chain is a call to the assign function. And that's no problem. Python says, okay, cool, Dave. Reseller sales is a data frame. Data frame has a function or a method called assign. Totally cool. What would you like to do? Well, I would like to create a new feature, a new column called profit. And what I'm going to do is I'm going to use a lambda, a little anonymous mini function. And by convention, we take a parameter of df underscore. You could actually call this whatever you want, but convention says use df underscore. That represents the actual data frame in question. And then what I'm going to do here is I'm going to go ahead and access the data frame, and specifically the sales amount column. And then I'm going to subtract off of it the amount in the total product cost. And here's what's going to happen behind the scenes. So the assign operator essentially treats your data frames as immutable. That means that they cannot be altered. And that's a good thing. So what assign, the first thing assign does is it says, look, I'm going to create an in-memory copy of reseller sales, and then I'm going to let Dave manipulate it using the assign method, which means that the results come back in a new object, which I'm calling reseller sales wrangled, and my reseller sales data frame remains unaltered. And this might seem like it's a lot of extra work for the computer, and it might take extra memory, and all of that is true. And most of the time it doesn't matter, because what's really important is making sure that your code works as intended, and just let the computer hardware deal with all the problems, essentially. Your expensive computer hardware is cheap, basically, is the way to think about it. So what'll happen is that in this in-memory copy of the data frame that gets created by the assign method, it'll say, hey, profit does not exist. It's not a column. It's not a feature on the data frame. So Dave wants to obviously create it. And everything to the right of the equal sign is the logic that Dave would like me to use to populate this new column with data. And what I'm using is a lambda, and I'm saying, hey, grab the sales amount data, the column, and then subtract off it line by line, row by row, sales amount minus total product cost, sales amount minus total product cost, so on and so forth, all the way down the length of the data frame. So I can go ahead and run that. And assuming there are no errors, I can then do this, just to show you that it worked. And it'll be, the new column will be added all the way to the end, and you can see profit right here. Nice. Okay, cool. And see here we have a loss, negative $721. Cool. So we've got that. So what we can do is take this code and copy it and then paste it. And what we're going to do is we're going to add a second column. And what we can do here is we can just say, hey, assign operator, excuse me, assign method, not operator. Okay, we're going to go ahead and use a comma, and now I can do something else. I can say profit percentage. And again, these, if you're a finance person, you might be like, Dave, these are totally incorrect. Just roll with it, please. So profit percentage is going to be reseller sales profit divided by reseller sales amount. Now, you might be looking at this code, you might be thinking, hey, that looks pretty reasonable. Dave just created a profit column. Now he's reusing it. But here's the fundamental issue. If I run this code, it's actually going to error out. And the reason for this is profit. It doesn't understand profit. And here's the reason why. Because notice that I'm creating the profit column on the in-memory copy. I'm not actually adding it to reseller sales. So this actually doesn't work. Python says, Dave, there is no profit column on the reseller sales data frame. And in fact, it's not. It's not there. It's on the in-memory copy that's created by the assign method. So that's no problem. What we have is our lambdas. Our lambdas, let me do this here. Actually, let's just do this. Lambda, df underscore, colon, df underscore. I'm just going to copy the sales amount here. Actually, sorry, that's not right, is it? No, it's supposed to be profit. Dave, geez, what are you doing? Okay, profit, df underscore, divided by sales amount. Now this will work. This code will work because when we use the lambda inside of the assign, like this little df thing is actually the in-memory copy. And this is great. This allows us to essentially chain all of our code here in our assign statement. We can do all kinds of data cleaning, data wrangling, feature engineering, whatever we need, all within one call to assign. And as long as we're using lambdas and these little df underscores, we can keep manipulating that in-memory copy, and our original data frame remains clean and pristine and unchanged, and we don't have to worry about any kind of funky copy semantics or anything like that. And if you're not familiar with the term copy semantics, don't worry about it, because if you're using assign, you're good to go. So if I run this, I get back a nice data frame. And if I go all the way to the right here, you can see my profit and my profit percentage. Awesome. So we love method chaining, and we love the assign method for pandas. I use this all the time. I shouldn't say all the time. Yeah, well, I mean, I was going to say all the time, but that kind of implies that maybe sometimes I don't. I use this 100% of the time when I'm doing advanced analytics using Python. Period, end of story. This is the way I write my code each and every day that I'm doing advanced analytics with Python. Granted, some days I'm not actually doing advanced analytics with Python. I'm using other technologies as well. But when I'm using Python, this is what I do. Okay, so what we can do is also start extending this. We can say, look, maybe that's not exactly what I want. So I also want something, let's say, sales extended difference. Okay, because in the original data frame, if we scroll back up, we have a column called sales extended. Actually, you can't actually see it, the extended amount here. Apparently it's elided. So that's okay. That's okay. Just trust me that it's there. So what we're going to do is we're going to say, okay, look, we've got this idea that in our financial aspects of our sales, of our reseller sales as Adventure works, we might often like provide discounts, incentives, that sort of thing. And sometimes we might actually sell stuff at a loss. That's basically what we're looking at here, this idea. So what we're going to do is we're going to go ahead and say, okay, we're going to use our DFs again, and we're going to look at sales amount. And then we're going to subtract off the extended amount. And what we're trying to look for is these negative situations where the extended amount of the cost of the order exceeds the sales amount. And when that happens, we're going to get a negative value. And of course, that's not real good for our business of AdventureWorks. So we're going to go ahead and go through that. And what we can see here is that a lot of stuff is 0, which is exactly what we had hoped for, right? The extended amount and the sales amount are exactly the same, but every now and then we can see, oopsie, everything's not right. So this is going to start helping us to understand the financial characteristics of these resellers that we're interested in, right? Those that have more than 35 employees, they're located in Canada and the US, and also what are their financial aspects? Because maybe they actually generate a lot of revenue, but it doesn't necessarily mean they're generating a lot of profit. So we want to make sure we're keeping that in mind. Okay, so let's go ahead and start expanding on this idea of using the assign method to perform our data wrangling. So let's go ahead and create a new section here. We're going to call this data wrangling. And what I'm going to do is I'm going to grab this code. And this essentially is what I do in the real world. I iteratively build up my code, typically with multiple cells in a Jupyter notebook. And then when I'm done, I will just keep the final version of this code right here within my assign statement. And then what I'll do is I'll either put it in a brand new notebook at the very top, or what I'll do is I'll delete all the cells in my current notebook that I don't need anymore. Because the idea is I'm trying to build this nice reproducible script from the top and execute each cell in turn. And usually my data wrangling code is usually pretty close to the top of my notebook. But as you're building it out, totally cool to use multiple cells. Just make sure you clean up your notebook, because otherwise you look at it 6 months later and go, what the heck was I thinking? All right, so We've got our data wrangling code so far. So let's go ahead and add some stuff. And you know what? One of the things that we want to do often when we're wrangling our data for advanced analytics or any form of analytics using Python is we want to extract out date features. We have raw dates in our data frame. We saw that earlier in our reseller sales data frame, but we can't really work with the raw dates usually. So what we want to do is extract pieces of it out. So for example, I want to extract out the order year. Lambda df underscore colon df underscore. Now check out what I'm doing here. I'm going to say, all right, I'm going to go to my data frame, my in-memory data frame, and I'm going to access the order date feature. And this is great because the order date feature has been transformed into a datetime object, and I can access it using the .dt method. So this accessor says, look, treat this column as datetimes. And we can go ahead and work with that datetime, and we can say, look, let's extract the year from the date as a number. So if I just run this, we can go over to the right and we can see, sure enough, here are the years, 2010, a bunch of stuff is lighted, 2013. Okay, but I don't need to stop there. There are just a tremendous amount of methods and features that are available to work with datetime data, and this is awesome. This is exactly what we want. So let's say order month. And what I'm going to do is I'm just going to copy and paste. And this is a good idea, by the way, because if you get a piece of code that works, why not reuse it as much as you can? And we're going to extract the month, and then we're going to extract the day as a number. And let's say I want the order quarter. So this is the quarter of the year based on the calendar. So January, February, March would be quarter one, so on and so forth. Got a little bit too carried away there. And let's see if we're going to call this quarter. And if I run this, and assuming there are no bugs, yeah, there are bugs. So we're going to actually make this order quarter. And then go over here and you can see how I'm adding all of these things. And of course, you see 12 and 11 are both a fourth quarter. Nice. Everything that we want. But we don't need to stop there because there are so many features, so many functionalities, so many methods of the datetime functionality of pandas. This is just great. So what we can do here is keep going. We can say, hey, actually I want the order month name too. Oh, okay, I need to fix my copy and paste here. That's not good. Copy and paste. This is all I want for my copy and paste right here. So we want the order month name. And then what we can do here is instead of accessing these attributes, notice that these are all attributes because notice there's no parentheses here. We're actually going to call a method called month name. Notice it's got its own parentheses. And then we can also say, hey, we want the order day name. Because often it's useful in analytics to actually have the months, the days represented as strings and not necessarily numbers. So we can paste in here, and then what we want is, well, that's not going to work now, is it? There we go. And then we're going to have day name. Now if I run this, you can scroll over to the right and you can see all the day names or month names. Awesome. Yes, you can abbreviate these if you would like. Once again, you can use ChatGPT or you can go old school and just Google it. There are many, many resources on the internet that'll actually show you, like, for example, how to actually get the first three characters of the month names and the order names using pandas. Okay, so what we've got here is a data frame with a bunch of really cool information in it now. So what we want to do is then say, okay, cool. We've got these resellers. They're large in terms of the number of employees they have. They're located in the US and Canada. We've got calculations regarding their profitability of their reseller sales, but we also want to know some stuff about products, the products that they sell as well, because maybe certain types of products are actually more profitable, more popular with these resellers. So we want to make sure that we understand this as part of our analysis. So we can go ahead and load the products data frame. And then we're going to call this products, and we go to PD read underscore CSV. And we'll call this products.csv. And then of course products info. And we run this. And what we can see is our products key, or excuse me, our products data frame is 606 entries or 606 rows. We got a product key, alternate product key, and we can take a look at the non-null values. And what we can see is that product category and product subcategory is missing some data. And we saw that earlier in the video. Standard cost is missing some data. And then status is also missing some data, because notice that these numbers are less than 606. So that's something we need to deal with. And what I'm going to do is show you how to deal with that using our handy dandy friend, assign. So what we're going to do here is we're going to replace missing string values in products data frame. So we're going to call this products wrangled. And of course, we're going to use our handy dandy method chaining here, because it makes our code nice and clean. And we're going to start with our products data frame here. 1, 2, 3. And you can use a tab, or you can use 4 or 5 spaces. I'm just using 3. That's just the way I roll. Your mileage may vary. Okay, so we're going to use our assign here. And what we're going to do is we're going to create product category. Now here's the thing though. So assign, as we know, creates an in-memory copy of the products data frame. And that's what we're actually manipulating. That's what we're actually wrangling with our assign code. If I have a column, a feature here that already exists in the existing data frame, assign says, Dave wants to overwrite the existing column with new data. So if it doesn't exist, it'll create it at the end of the data frame, as we saw earlier. And if it does exist, it's going to be overwritten in place with everything to the right of the equal sign. So what we're going to do here is we're going to say, okay, cool. We're going to grab our lambda df : df underscore, and we're going to say product category. We're going to access that column, and then we're going to invoke a method called fill NA. And this says, look, go through every value in the data frame. Excuse me, every value in the column, every value in the series object, and check it. If it's empty, that's what the NA means. If it's missing, if it's NaN, not a number, or NA means not available, you can then say, look, fill it in with another value. And we know that this is a column of string values. So we're going to say, look, any place the data is missing, just replace it with the string missing. This is what's often referred to as a sentinel value. This is a specific value that tells me something about the data. And in this case, this is my sentinel value for missing data. Because sometimes it's useful to have a value that says the value is missing rather than just working with the actual missing value. And as you move into advanced analytics, that'll make a lot more sense. So just trust me on that. Okay, so product subcategory. So I'm going to go ahead and grab my code here. I'm going to copy it, and I'm going to paste it, and I'm going to say product subcategory missing, and then of course I need comma, and then I'm going to do status. Status, and then I can, just for grinsies, I can put out products wrangled. Now, assuming I didn't, well, I did make a bug. df underscore, oh, right here. Bad juju. Okay, there we go. Oops. There you go. Okay. And what we can see here is I filled in missing values. You can see missing, all that kind of good stuff. So that's cool. That's good to go. We've got this filled in. Now, notice that we didn't fill in standard cost. And this is a little bit more complicated because filling in string values with missing is actually pretty easy, and it works very, very well in many analytical scenarios. You want to be very, very cautious about replacing missing numeric values with sentinel values. So for example, if you replace this with 0, it's entirely possible that you actually have products with a standard cost of 0 in your catalog. I've seen it before. It actually happens. So that might not necessarily be a good sentinel value. It's commonly used to represent missing data, but then you have to interpret to say, look, this numeric column will never be 0. So if it is 0, that's actually a sentinel value for missing data. Another thing that you might do is put a negative number in here. I've seen that as well. That comes with its own problems. So in general, if you don't have a really good reason to replace missing cost values or numeric values with something, then just don't do it. Just leave them missing like this. Okay. So we've got some things that we also need to work on in terms of our resellers as well. So remember we talked about how we want to only include large resellers, those that are over 150K in revenue, have 35 or more employees, and are located in the US and Canada. So what we can do here is actually write some data wrangling code to set up a data frame for us. And not surprisingly, what we're going to do is we're going to wrangle the resellers data frame, and we're going to call this resellers wrangled, because we have reseller sales wrangled, we have product wrangled. You know, it's nice to be consistent. And we've got our handy dandy method chaining here. Whoops. And we're going to go to resellers, 1, 2, 3, assign, and then open parenthesis, close parenthesis. Okay. So here's what we're going to do. We are going to start not with assign, oddly enough. This is the real power of method chaining. We're going to start with query. Remember we were writing queries? And then I was showing you how you could query. You could chain queries together, and this is how you actually do it the right way. Okay, so what we're going to do here. So first up, we're going to start with our resellers data frame, and we're going to query it down to those where annual revenue is greater than or equal to $150,000 a year. And I'll be polite. I'll use natural language here. And the number of employees is greater than or equal to 35. So what'll happen is resellers, this data frame will run the query method on itself. It'll filter itself down to only the rows of data that meet these criteria. And then I'll get back an in-memory copy of that data frame. And then the first thing I do is I query that in-memory copy once again. And I say, okay, cool. And what I want is country region name in the list that is composed of, whoops, got to use double quotes. Canada, yeah, hopefully yep, that looks like I spelled that correctly. And double quote, United States. I better be able to spell that correctly. And then there we go. So we filtered the original data frame down twice, query, query. So we just have now our large resellers in the US and Canada. And then we can say, okay, cool. What I'm going to do now is create a new feature that could be potentially interesting for my analysis called revenue per employee. And what I'm going to do is my lambdas, of course, lambda df underscore, make sure you get that underscore, df underscore. And what we're going to do is take each annual revenue of the filtered down data frame. Right, that's what I'm working with. And then we're going to divide it by df underscore number of employees. And resellers wrangled. And assuming that I don't have any bugs, which I do, not surprising, number employees. Well, that's not correct now, is it? Employee. Here we go. Yay. All right, now we're good to go. 269 rows like we saw before, and we can see over here the revenue per employee. Whew. This is not a good business. At least for AdventureWorks, right? This is the revenue per employee purely from selling AdventureWorks products. Hopefully these stores, these resellers actually have other products that they're selling as well. Otherwise, they're not going to stay in business long. All right, moving on. We've got our tables set up for our hypothetical data analysis. What we need to do is now combine all of these tables. Because generally speaking, when you're doing analytics, you tend to work with a large data frame, large table of all the stuff all merged together. And the first thing that we're going to do is we're going to cover what are known as left joins. Now, if you're familiar with SQL, structured query language, this is old hat for you. If you're familiar with Excel and you've used it a lot, this is the realm of VLOOKUP and XLOOKUP, the way we can merge two tables. These are technically called left joins. So let's talk about what we're doing here. So first up, let's take a look at our reseller sales wrangled data frame again. So I run this, resellers, there we go. What we can see here is we have a product key and a reseller key. And what we've created are wrangled product and reseller data frames that we need to combine with this, because what we have here are our keys. These are the unique identifiers to say, look, this row of data is related to the row from the product's data frame that has the key or the identifier 349. It's also associated with the reseller with the reseller key or identifier 676. So what we need to do is take those data frames that we created and then combine them with this data frame. And this will be known as a left join because we're going to keep this table on the left. And this will make a little bit more sense when we actually see the code. So let's talk about that. Or actually, let's write the code. Actually, that's not right. So now, technically, there is a join method on data frames in pandas, .join. However, those will actually work on indexes, which you almost never use in the real world in analytics. What you typically want is something called the merge method, because the merge method allows you to join on columns. So we're going to use the merge method to left join products to reseller sales. Okay, reseller sales is our frame of reference. It's our context. This is the table that's on the left. And then what'll be on the right is products. And let me show you what that looks like in code. So what I'm going to do is I'm going to call this the resulting data frame left join. Terrible name, but just roll with it, please. So notice what I'm doing here inside of my method chaining code. I'm starting with reseller sales wrangled. And the easiest way to think about it is we know that reseller sales wrangled is the left table on this join because it is to the left of the call to merge. Not merger, merge. There we go. Notice that this object is to the left. I'm invoking merge on this data frame, which means it is the left table. And then my right table is what goes inside of the merge. Okay, so I'm saying, hey, pandas, start with this data frame, reseller sales wrangled, call merge on it. And it says, okay, Dave, what do you want to do? What table do you want to combine with this one? And I'll say, hey, use product wrangled. And it says, okay, fine. You need to tell me how you want me to do the merge. And since I want reseller sales wrangled to be on the left, I'm going to say, try and use a left join. Now, here's what's super interesting about a left join. It tells pandas, hey, every row of data that's part of the reseller sales wrangled data frame should come back as the result of all this code. Basically, take the data in this data frame and try to merge it where you can with products wrangled. And if you can't, that's okay. Just leave those pieces of data blank if you can't find a match. Now, in general, this is going to work just fine with this particular data set. But oftentimes what will end up happening in the real world is you'll try to combine two tables and you won't necessarily have matches for everything. So left join, a left merge here will preserve all of the data from the original data frame. And that's usually what you want most of the time in analytics. So let's go ahead and see some info about this bad boy. And what we can see here is after I join this, notice I have more columns than I had before. So if I scroll down here, you can see here are all the features that we added. And then on the end, we have product alternate key, product category, product subcategory, category, product name, product cost, standard cost, and status. These are the columns from the product's wrangled data frame. But notice that what we don't see here is the product key, because the product key is actually all the way up here. And Pandas is smart. It says, look, these columns are named the same thing. So I'm not going to duplicate the column for you because they're named the same thing. So I'm going to assume they're the same data, so there's no point in having the column in there twice. And notice this. Notice I didn't specify in my merge call here what column to use to match up the data. And we know it's the product key column, but we don't have to specify it because what ends up happening by default is the merge method says, look, anytime I have the same column names in the left table and in the right table, I just automatically pick those for the join. Now, if you're familiar with SQL, this probably makes you very nervous. I know it makes me nervous, but this is the default behavior of Pandas. But let me show you a better way to write this code. This will work, but don't do it. This is the better way to do it, which is you specify directly in the code what column you want to use. So do a left join, please, where reseller sales wrangled is on the left side, products wrangled on the right side, and join on product key. Use that to actually match these things up. Now, we can go ahead and add more merges here. We can method chain merges because we also want to join up our resellers wrangled data frame. Okay. And we're going to go ahead and do how equals left. And now we're going to do reseller key. And the new and improved left join, let's go ahead and grab the, well, you got to spell it correctly, Dave. Wrangled. There we go. And now we can see after these are the last two product columns, now we can see the reseller stuff added to it. So we're increasing the size of our data frame. Now notice this though. Notice this, that we have 60,855 rows coming back. But that's probably not correct because remember the 60,855 rows is the sales activity for all of our resellers. But our resellers wrangled data frame actually only has Canadian and American resellers that have 35 or more employees and generate 150K or more in revenue. So this left join isn't exactly what we want. We actually want to filter all the data down to only those rows that correspond to the reseller's wrangled data frame. And by the way, common question that I get asked is, hey Dave, what if the names of the columns are not actually the same? And we can totally do that. Let me show you how you do that. So let's say, hypothetically speaking, this is not the case, but let's say, hypothetically speaking, we had product key in our left table and we had product ID in our right table. They're actually called product key in both data frames, but let's just say that they were different that way. So what we do is we just say, hey, the left table's column is called this, left on. And then what we do is we say, not surprisingly, right on equals product ID. And that's how we can specify for the merge to Python, hey, use two different columns and two different names. I assume not two different columns and two different names. That would be 4, right? No, columns with 2 columns, each with their own name. That's the way to say it. Okay. Now, I've also often asked, hey, Dave, what if I want to do a multi-column merge? What if I have more than one column at the same time? And we can totally do that as well. So what you do is you just use a list. So hypothetically, let's say we have call 1, call 2, and you can just create more and more in the list. Okay. And what you do is you just specify the same thing over here. Let's call this foo1, foo2. And this is how you actually can use multiple column joins and also specify the names as you need. Now, these have to match positionally, right? So what'll happen is the first item in this list will be compared to this item in this list for the matches. Then this one to this one, so on and so forth. And as long as all of the identifiers match up, for example, if we're using numeric identifiers, they all have to match up. If we're using string values, they all have to match up. As long as they all match up, it'll work just fine. So that's how you can actually do more complicated merges than what we're talking about here. But we don't need to worry about that because we're using a pretty clean data set from a data warehouse, which is pretty typical in my experience when you get the ability to use a warehouse. You don't have to do all this kind of stuff. As we just saw with left joins, we're preserving all of the rows from the reseller sales wrangled data frame, all 60,855 rows. But we know for our analysis, that's not what we want because we filter down the resellers wrangled data frame to only large resellers in the US and Canada. So what we actually need is a different kind of merge. And the merge that we need to actually get everything down to the rows of data that we care about is known as a inner join. Inner join. And basically the way this works is, as you're combining tables, only where you have complete matches between the tables, between the data frames, that's what you get back out. So that's a bit abstract. So let's go ahead and build this piece by piece. So what I'm going to do here is I'm going to go ahead and grab this code here, and I'm going to modify it. So we're going to inner join. And I'm going to call this object inner join. Terrible name. Don't use it. Use something more intuitive. And look what happens here. So we've inner joined reseller sales under products wrangled. And what ended up happening was every value of product key in the reseller sales wrangled data frame had a corresponding match in products wrangled. So one way this could happen is, for example, our products wrangled data frame contains a lot more products than we actually end up selling in our reseller sales wrangled data frame. So we actually get back all the rows. All these rows come back. Now, if we copy this, actually, no, let's copy this one and modify it. So we're going to inner join again. And we're going to do inner and inner. And notice that we only get back 25,581 rows. And the reason for that is these are the rows in the reseller sales wrangled data frame that actually have reseller keys that belong to the large resellers in the US and Canada. And that's why we get a much smaller list. And that's the difference between left joins and inner joins. In general, at a high level, based on my experience doing analytics, you tend to use left joins the vast majority of the time. The only time you tend to use inner joins is when you know for a fact that you want to whittle the data set down. Usually why I use left joins is because I want to preserve all of the data, all of the rows, and what I want to do is find out where the data is missing. And then I can go, well, why is it missing? And I can go speedlink into the data, go talk to the business subject matter experts, that sort of thing, and figure out why the data is missing. But in this particular case, for this hypothetical example, this tutorial example of doing data analysis, an inner join is what we want because we only want to look at the sales data for just the rows that correspond to the largest resellers in the US and Canada. Okay, as it turns out, we got a bit of a problem. So what we're going to do here is we're going to aggregate our data. We're going to group and aggregate our data. So we're going to talk about group by and AGG and AGG, these two methods. And to understand why, let's take a look at our reseller sales wrangled data frame again. So if we take a look at this data frame here, what we can see here is sales order line number. And this is a very common representation that we see out of business systems and data warehouses, where notice that the sales order number is the same. 43, 65, 9. Okay, this right here. It's repeated over and over again. And what we actually have is the sales order line numbers. So what this is a breakdown of individual sales orders by the products. Each sales order line number corresponds to, hey, I bought this kind of bicycle and I bought this amount, and then I bought this other bicycle and this other amount, so on and so forth. So from a high level analytical perspective, this isn't what we need. What we want to do is aggregate this information. We don't want to have 5 rows of data for each individual sales order. We just want to have 1 row for the sales order for the particular analysis that we're doing, because we're trying to figure out, hey, what's going on with these guys in terms of like their profitability, what kind of products they, what products they're interested in, that sort of thing. So what we're going to do here is create an aggregation. And here's how we do this. We're going to do sales order AGG. That's not a bad name. And we're going to use some method chaining here, not surprisingly. And we're going to start with our inner join data frame, because that's the one that has been whittled down, has been filtered down to just the largest resellers in Canada and the US. And we're going to go ahead and 1, 2, 3 dot group by. Now, if you're familiar with SQL, structured query language, SQL, group by is totally familiar to you. If you're not, but if you're familiar with spreadsheets, this is like creating a pivot table. And what we're going to do is we're going to say, hey, pandas, what I want you to do is group the inner join data by the unique values of sales order number. Okay, if you will, this will create a bucket for every unique sales order number. And then what we want to do is put rows of data inside these buckets, and then we can do stuff to the buckets. So, not surprisingly, one of the things we can do is we said, once we've got all of our sales orders into the various buckets. So, for example, what we saw earlier, we have a bucket for that sales order that we looked at earlier. And if we look inside the bucket, there'll be 5 rows of data inside that bucket. And then what we can do is we can say, look, hey, pandas, inside of that bucket, what I want to do is access the sales amount column. Please. There's all kinds of data in that bucket, but I'm actually only interested in the sales amounts right now for the bucket. And Panda says, okay, cool. You just want to work with the sales amounts for each one of the buckets. Each bucket corresponds to a unique sales order number. What do you want to do with this, Dave? And I can say, hey, pandas, I would like to AGG or aggregate the data. And what I would like you to do is use the sum function, the sum method, to sum all the values up. So what I should get back is a data frame where every row corresponds to a unique sales order number. And what I'll get is the total sales amount for that. So if I have 7 sales order line numbers, let's say, I'll get the sum of all 7 sales amounts coming back. And let's just take a look at what that looks like. And voila. What we can see here are the individual sales order numbers. And then we can see the amounts, the summed amounts. Now, what's particularly interesting is we can do all kinds of cool stuff with this. Now we can say, hey, this aggregation, let's get the summary statistics for it. And get summary stats for aggregated sales amount. And what we can see here is something that's really super interesting, okay? We've got a mean of $21,729. So on average, the aggregated individual sales orders generate about 22 grand, let's say, a little less than 22 grand. But notice this. Notice that the median is far lower. It's less than half at 94.75, which tells us that we have this skewed distribution. We have a skewed distribution. That means that some of our sales orders are much, much larger than others. And you can see here, the biggest one is a whopping $164,000. So of course that's going to pull the average up. So that's super interesting. Even within our largest resellers in the US and Canada, we've got a wide distribution of what's going on. So not surprisingly, what we can do is we can say, hey, let's visualize this. Well, let me spell that correctly. Let's visualize this. And we're going to go ahead and grab sales order AGG, and we're going to plot, and we're going to use a histogram. And sure enough, what we can see is the vast majority, well, I shouldn't say the vast majority, a large number, a huge number of our orders are pretty low, between $0 and maybe $12,500. And that mirrors what we see here. We can see the 50th percentile is 94 of 75, so it's probably like way down here somewhere. And we can see this long tail. That's going to be super interesting. That's one of the things that we want to do in our analyses. We want to create hypotheses, start exploring the data, and then dig into the data to start understanding the why. Now, this can be kind of useful, but what's even better yet is if we can actually figure out on a per order basis, per sales order basis, some various statistics. This is very much like what you would do using SQL, if you're familiar with SQL, with a group by and aggregate functions, or if you're more familiar with spreadsheets, this is going to start to look like a pivot table. Okay, so I'm not actually going to create a brand spanking new data frame from this. I'm just going to demonstrate it for you in line here. So I'm going to use method chaining because we love method chaining. 1, 2, 3. And I'm going to group by, once again, my sales order number. So I'm going to get a bucket or a group for every unique value. I'm going to access, once again, the sales amount column for each bucket. And then I'm going to say, hey, pandas, please aggregate this, but I want you to actually use multiple calculations. So what I do is I can just provide a list of the various calculations that I would like to see. So we can say, hey, give me the sum, give me the min value. So this would be the minimum sales order line number, right, per sales order, the max, and the average. And what I get back is a data frame. And you can see here for sales order number 43661, the total value was around 33 grand. The minimum, in this order, the minimum sales order line item was only 20 bucks. And then the max was about 8,100 bucks. And then the average sales order lines were around 2182. Okay. And this is some pretty useful information. Now, one problem that we have, though, is notice this. Notice that this data frame that comes back is using these values here, these sales order number values, as the index. So that's a bit abstract. So let's say, so if I call info on this thing, notice that the only columns I get back are sum, min, max, and mean. The actual sales order number is actually considered the index. It's not actually part of the data frame. And that's almost always not what we want. So what we want to do is we want to fix that. So how we do that is pretty easy. What we're going to do is use something called reset index here. So I'm just going to go ahead and just demonstrate that for you. Reset index. And now what we get back is a data frame where sales order number has been pushed out of the index and into a full-blown column. And you can see here now we have an index, right? A standard numeric index, which is off on the side. And this is typically what we want. So almost always when we're using group bys and aggregates and that sort of thing using pandas, we're almost always using reset index because we want to push in those indexes into the actual data frame so we can use it. Okay. So moving on, we might be interested in more than just the actual sales amounts. We might actually want to use the profit columns as well. Because as we know, it's entirely possible that we're selling stuff, but we're selling it at a loss. So we're going to go ahead and calculate order line statistics for sales amount and profit columns. So we're going to start with inner join and 1, 2, 3. We're going to group by again. We're going to group by sales order number. Now this time what we're going to do here is we're actually going to use a list. It's a very common pattern using pandas. So we're going to say, hey, pandas, for each bucket, for each individual sales order number bucket, I want you to look at both sales amount and profit, please. And Panda says, okay, no problem, Dave, I can do that. Actually, we don't need a dot here. Boop, there we go. And then we're going to AGG again, and we're just going to go ahead and do the same thing. We're going to say, calculate the sum, calculate the min, calculate the max, calculate the mean or the average. And then, of course, what we're going to do is we're going to reset the index. Well, actually, let's not do that. Let me show you what happens if you don't reset the index. And what you can see here is my sales order number, once again, is out here as an index. And I get this weird kind of hierarchical structure. It's kind of interesting structure where notice how it's sales amount and then the sum, min, max, mean. That's, usually not what you want most of the time. But let's see what reset index does. Now it pushed sales order in, but notice I still got this funky kind of two-tiered setup of sales amount and profit for like my columns and then sum, min, max. This is typically not what you want. So usually what we end up doing is actually defining our own specific columns rather than relying on this kind of generic kind of thing and hoping that Pandas creates something that we can use. So let me show you how you can do that. So we're going to group by sales order number, and we're going to define our own aggregations. Okay, so what we're going to do here is we're going to start with inner join, of course, once again. 1, 2, 3, group by, and we're going to group by sales order number. And notice what we're doing here. We're not actually going to access the columns directly in the buckets. We're going to say, okay, you've created the buckets, totally cool. And now I'm going to specify specifically exactly what I want you to do in terms of the aggregations. So sales amount total. So I'm defining my own column here, my own feature, and I'm saying, hey, how you build this, Pandas, is by going to the sales amount column and then applying the sum function to it. Now, this is a tuple. This is a data structure in Python known as a tuple. And this tuple says what column and what aggregation. What column, what aggregation. So I can also do another one here, and I can say profit total. And I'm going to do another tuple. And this time I'm going to use profit. And I'm going to use sum. Now, of course, I could also do something like sales amount min, tuple with sales amount and min, so on and so forth. I can create as many of these as I would like. And then, of course, I'm going to reset the index. And if I run this, see, now this is exactly what I want, right? This is a data frame. Let me scroll up. None of this funky two-tier stuff. This is exactly what I want. And this is typically what I'm doing when I'm writing code like this. I'm actually creating my group bys, creating my buckets, and then I'm specifying step by step exactly what aggregations I want. And then, of course, I'm calling reset index, so I get a nice data frame that I can actually work with. Now, what if I want to group by multiple columns at the same time? I can totally do that. So what I'm going to do here is Group by product category, and then by sales order number. And we're going to start with inner join once again. Terrible name. 1, 2, 3, group by. Now, not surprisingly, I'm going to use a list. So I'm going to group by product category. And by the way, this is showing the power of having that combined data frame, where I can pivot it and slice and dice it any way I would like, and sales order number. So group by product category first, and then within product category, group by sales order number, which means the same sales order number is going to show up multiple times. Because first of all, we're going to say, hey, maybe sales order 1, 2, 3 had 3 line items. Each line item is from a different product category. So that sales order number will show up multiple times, totally expected. And then what I do is my AGG, and I can do sales amount total equals a tuple of sales amount and sum, once again, whoa. And profit total, as we saw earlier. Profit and sum. And if I run this, assuming I don't get a bug, what's the bug here? Oh, I capitalized sum, it looks like. That was a bad idea. Boop. And, whoa, check out what we get. This is what's known as a hierarchical index, which kind of makes sense, right? For accessories, that was my product category. Here are all the individual sales order numbers that had sales order line items that were in the accessories product subcategory or product category. Same with components, so on and so forth. So this actually makes sense insofar as this is exactly what we specified here by our group by. But there's an easy way to fix this, not surprisingly. Reset index. Boom. And this is the style of data frame that you need. Okay, that's it for this crash course tutorial on pandas, using pandas. As I mentioned earlier, the next video in this series is going to be talking about how to do data visualizations using a Python library known as Plot9, which is super awesome. But this is enough to get you started. Like I've said several times, ChatGPT or old school Google will certainly help you out with any sort of pandas questions you have. There's many, many sources of documentation for pandas. And by the way, in case you're interested in getting a really, really good book on pandas, there is a book by a gentleman by the name of Matt Harrison, and it's called Effective Pandas. And that's available by, I'm just going to, that's terrible. Okay, told you. No editing. So Matt Harrison, that's the author. His book is called Effective Pandas. Totally get it. You can buy it from his website directly to get it in an ebook form. You can also get it from Amazon. Can't recommend this enough. This is a great, great book for learning a lot more about pandas. Okay, that's it for this video. Hope you're enjoying the series. And until next time, please stay healthy, and I wish you very happy data sleuthing.